Good afternoon, everyone. Thank you for joining us for the third webinar for TopSolid 2022 today. This webinar, we're going to be focusing in on TopSolid'Tooling, which is TopSolid Split, Mold, Progress, and Strip Design. I think we're expecting a few more people to log in, so while we wait for them, I'll introduce my colleagues that are with me. We're joined by Joe Hart, our technical manager, and Mike Kay, our sales manager. All right, let's get started. So, as I said, we're going to be focusing on split and mold and progress and strip design today, so let's just dig right into TopSolid Split. So, we moved some of the options around in TopSolid Split that formerly were located under Tools options. We have instead decided to move them under the Document options. So you can see on the right-hand side of the window right now, under Options, you see Colors and Stock. This way you can create different templates with different colors already defined, different stock margins already defined. It's a little bit more useful. For those of you not familiar with where the options are, why don't we just go show you real quick. If I go into a split document, why not this one? I'm talking about having the options activated here, which I already have. And right here is where you have access to setting the colors and the stock margins. For example, I can double click on stock, and I can go here and set the stock margins at whatever I want them to be. Whatever. And now this document has that set. Again, you can set this all in a template document as well. Alrighty. Next, parting edge selection. So we have added a new function to parting edges to help control the selection of edges. In some cases, it was hard to get the edge profile you wanted or partial profile that you wanted because you don't want the whole edge profile. So we've activated under the advanced options of parting edges, right down here, a new single edge selection. And then the rotary selection gives you the selection possibilities further along. And again, let's go to the live sample and have a look at it. So here you can see I have my parting edges already, my suggested parting lines already created. So if I go to my parting edge command and I'm on single edge selection, notice it only lets me select, the uncandidate edges, it only lets me select by default one edge, okay? If I turn that off, for example, it goes for whole loops, right? Anywhere that it can go to tangency. So it's just a further control for you. Now, if I have single edge detection on, and for example, I hold my left button down, tap my right, I get to the next tangency, tap my right again, I get further along in that tangency. Okay? And then we can come in here, and of course, we can do what's needed to get all of this parting line defined. And yes, for those of you who didn't know, you can drag those balls along the parting line as well to get the parting line definition completed. If we progress through here, again, even on internal edges, so we'll need a parting edge right here. With single edge selected, I'll turn candidate edges off here so I can select on edges of the model. You can see here, it's only selecting one edge. Rotative selection selects the whole loop. Okay. And now let's go ahead and let's just bang out the rest of these really quick so that we can, get to where we need to be. Oops, missed that one. I like to group similar parting edges with each other. It's a personal preference. It's not really necessary. And we'll grab that one. Perfect. All right, so we have our shells created, right? Which is good because we'll use them moving forward, I think, in the next slide. So let's go back to our slides, have a look. So now with vector profiles, you have the ability to control the length of the vector. It used to only be you could type in a length, 3 inches, 4 inches, 60 millimeters, 100 millimeters, whatever. But now you can have them limited by either the stock plane or a specific plane. Okay, so let's go have a look at that. So if I want to go create a vector, we'll go to vectors here, and I'm just going to pick one right here for giggles. All right, and you can see right now I have a length limit, right? So I can control the length using the slider, or we can set it by a stock plane, which is going to go to the standard stock planes that were created when we defined our shape to split, okay? Or to a specific plane, in which case you can choose the plane you want to work to, okay? And it's going to extend it out to that length there. So it's up to you on how you want to do things. It's just, again, another control made available to you. All right, so now from here, let's take a look at the next one. Planar parting surfaces have been improved, and they've been improved by being smarter about the detection of other parting edges that are on the same plane. In fact, the way it used to work is you would select an edge as your start, you'd have to select an edge as your end, and then sometimes you'd have to invert the flow direction for how it's looking at it. Now the software does a much better job. When you select the starting edge, it goes along the first flow direction it finds, and it stops automatically at the last segment that's on the same plane. If you invert it, it automatically inverts it. Let me show you what I mean. Go. Let's go to parting surfaces. We'll go to plane. If I select right here, for example, you see how it auto-selected all the way to the end there? That's the end plane, okay? Now, if we start this command again, go to planar, and I start here, it's going to my left and stopping on that segment where the plane stops. If I flip this, it automatically finds the correct termination over here. And of course, if you wanted to change the termination edge to be something else, you of course always have the control to do that. Alrighty. Next, the automatic parting surfaces, start edge and direction. So the calculation of automatic parting surfaces depends on the start edge and the processed parting line and the direction of this line. In order to stabilize the results produced by the command, this origin and direction are now determined in a constant manner with respect to the mold frame. Okay, that's just a lot of words telling you that we made the command more consistent. So in addition, you can now select the start edge and reverse the direction of the path. These new contextual commands are available by right-clicking on the list of available parting lines. So let's go have a look. Again, we'll go back to here, and we'll just use this one. Why not? So we'll go to automatic, okay? I'm going to say I want to use partial. I'm going to zoom over to here. I'm going to say my start edge is that way. I want to flip that way. And I'm going to say my termination edge, in this case, will be over here. Why not? And let's see what we can do. So we can say compute parting surfaces. And if you notice, it auto created a nice extension there, nice planar. Now it's making a nice transition here. And you have a really clean set of parting surfaces. And this is all done in automatic mode with significantly better control. Alrighty. Shells and previews. So in some cases when you're designing really big cavities and cores, really big molds, the calculation of sewing each of the parting shells can be quite time intensive, okay? And generating the preview makes it even longer. So we've added the little eyeballs that you see up there when you create your parting shells. You can turn those off so that the preview of this doesn't show up. Now, of course, if you turn this off, you won't see any of the potential errors that are happening in the parting surfaces, gaps, duplicates, overlaps, whatever. But if you know it's clean already, this is a way to win some time. Alrighty, let's go take a look at TopSolid Mold. So within TopSolid Mold, there's a couple of nice improvements. First one has to do with a new set that's been created. We're calling it the other set. So this is just to give you quick access to another grouping or another group of sets to manage things that are not part or to be considered part of the A half, the B half, the ejector, and so on. Okay, so it's just another additional set to work with. As you can see, it's available in the quick view bar down here. If you want to use this new set on old data, meaning molds designed prior to 7.16, you have to right-click on the Sets folder in the Entities tree and choose Recreate Mold Sets. And then it will add this new other set. Okay? I'll show you that right quick. Goes out of that. All right, so this mold was created in 7.15. If I go to my Entities tree and I go over to my Sets and Categories, you can see there's no other set there. So if I right-click on this, I can say Recreate Mold Sets. And now you're going to see that other has been created. Okay? And now you can move things into those sets like you would normally. It's up to you to manage what you want to put in. All right, next, cooling. We reorganized the commands a little bit. So until 7.16, most of these commands were only available in the contextual menu, meaning the right-click menu. And for some users, that was a little difficult to manage. So they still exist in the contextual menus, but we've also grouped them together into a cooling sketch section, make them easier to find in that right-click menu. And in addition to that, the commands are now all grouped at the end of the 3D sketch menu. So as you can see in the bar below, you now have access to all of the sketch commands right there. Next, conformal cooling. I don't know if any of you guys have ever used conformal cooling, but up until now, it wasn't really supported by TopSolid, so we've added a new command within the cooling commands called U-shape. So it's up to you to design up your conformal path. You can use the 3D pipe command to do this relatively easily. And then you can take that solid, and when you're inside of a cooling environment, you can say, use this shape as cooling. And you can specify the entry and exit of that conformal cooling. The advantage of this is then that conformal cooling is usable with the circuit processes, with the safety margins, with the collision analysis, with the leak analysis, and so on. So it's an important feature to support, and it is now supported with the use shape option. Another thing about cooling, definition of circuit for imported parts. So sometimes you get your mold designs from an outside design source, and you want to bring them in, and you want to be able to run all the cooling analysis, collision checks, and all that kind of stuff on them anyway. So as long as you have TopSolid Mold installed, you can now go to the Shape pull-down menu, and you can define the circuits that are supposed to be considered as cooling circuits. Then you can go into TopSolid Mold with that shape, and then you can run all of the analyses. So if I go ahead and hop into TopSolid again here, open this up. So this is already done because I did it without and I saved it, but that's okay. I can show you anyway. The way it works is quite simple. Shape pull-down menu. And here you have cooling shape. So the shape to analyze, that shape, and you choose the border edges. So for example, I'm going to choose that edge, and that connects right to there. And you do this for each of the cooling circuits. So if there was multiple lines coming in, you have to choose all of those edges. And then this is defining the cooling shapes, which in turn, and I'm going to get rid of them because I don't need them, which in turn then allows you to run any of, the analysis inside a mold. So we'd have to bring this into a mold document, but then you can run any of the analysis tools inside a TopSolid Mold. Perfect. All right. Would a mold like this need to be 3D printed? Oh, now we're talking about the one with conformal cooling. So if we are, conformal cooling is done a couple of ways. One is by 3D printing the insert out of 3D printable metal. There's also, I think, a process called laser synergy, which creates the conformal cooling inside the steel. So something along those lines. All right, let's go back to our presentation. All right, next, pins, coloring the trimmed faces. So In the past, when you put in an ejector pin in TopSolid, it did all the fancy trimming, put all the clearances in, and that's fantastic. The thing it didn't do is match up to the colorings for the mold surfaces, the parting surfaces or shut-off surfaces. So now it does. Okay? So if I go look at that, mold. And okay, so we already have a ejector pin in here, but I'll go edit the pin and just show you where the process to do this is. So it's down here. You can see we have the color faces command active, okay? And the color faces is going to absorb the color of the molding detail, all right? If we are trimming it to the shape. If we're trimming it to a plane, okay, and we're going to say it's the top plane, I'm making a mistake here, but anyway, if you trim it to a plane like this one is, here, let's get out of it. So this one's being trimmed to a plane, okay? And it's the top plane. Oh, that's what I did, okay. So we want to be on shapes. You trim to the top plane. Then what happens there is because it's not being trimmed by this detail, it's to the highest Z detail and making it a planar trim, the coloring stays uncolored because it's not matching anything, okay? And if an ejector pin was passing through, oh, let's say molding detail and shutoff detail, then it would be both colors across there. Show you back in here. So you can see this pin is right here, which is passing through the shutoff detail here and the molding detail here, so it's got both colors on. It's just a great way for the people manufacturing the pins to understand what's a shutoff face versus a molding face. Just to note, the new mechanism can only be applied to new documents created inside of 716. If you are upgrading from 715 to 716, the coloring won't work on the old files. All right, so a couple things. You might have seen this in the TopSolid design sample. So we have markings, which is the ability to automatically mark our plates, for example, as well as we've done this primarily for pin markings so that we can automatically identify ejector pins and which ejector pin hole they go in the pin plate. So if we go take a look at both of these, look at the markings. Very real quick. So I have a marking event here, okay? So this marking event is coming from the modeling page right here, right there. I selected the plates. I'm using my manufacturing index, setting the font size I want, the locations I want, and off it goes, and it marks the plates. If I go to my pin markings, again, it's the same thing. The one advantage of the pin markings command that's in Mold here, it's a little bit more intelligent, is you can detect all the pins automatically. And it will detect the pins and the plates that need to be marked. And then off you go, and everything has its corresponding identity in. So it takes no time at all, but this way it will show up in your drawings, it will show up in the CAM files so that they can engrave them. It's a really, really nice new command. Okay, next, a couple things about angle pins. So first of all, a new graphic cut command is now available in the angle pin pocket, and slide joint commands. It's located in the right of the design space during the use of the commands. It allows you to either enable the graphic cut or not to facilitate the inclusion of the pin, so you can see what you're working on. Okay, and you can configure the attributes of this cut in the options of the mold. Now, if I go and show this, let's go to here, go to movement, mold, and I'm just going to go into my angle pin command, just to win some time. So you can see my angle pin was already placed. Right here is where that's located. So it automatically is cut to the center of the pin so that you can see more easily what you're doing. Okay? And then from there, this is the last improvement for TopSolid Mold for this year, is we have improved significantly the slide joint command. Okay? And it works basically more localized, like you see in my screenshot there, so that when it disengages, it's not having to check against other objects, where it was automatically trying to check against collisions with other objects, which made it kind of heavy and more complex molds. So let's see if I can show this one live to you. So if I go to make a slide joint, angle pin rigid group is this, slide rigid group is that, the angle pin itself is that. Okay? And like that, click OK. You've made the joint. If we go here to mold simulation, hit OK, let it rebuild. And I'm going to zoom this around a little bit so you can see. Now as I simulate this, oops, let's go up here. Now as I simulate this, you see the slide is moving here. And as soon as that disengages, the slide stops moving. And now it's being pushed back by the pin and the final push of the back lock. Okay, so significantly quicker response time to that new command, or that newly updated command. Alrighty, so let's look at strip improvements next. These are just a couple of little ones. It's not really worth showing anything live on this one. With drivers, in order to facilitate the position of the pilot symbols on the strip, a filter full circles advanced option has been added to allow you to select only complete circular edges. Okay, it's pretty straightforward. The unbending of a bend, if you watched the sheet metal improvements yesterday, you will have seen the exact same command. It's just inside of the strip layout. So now you can take conical bends and unbend them to create the necessary steps in your strip design. And then progress is the final one. And with progress, again, it's just a little one. The modeling tolerance set in the options of the template used to create the punch document is now used to create the punch operation. So it's just how you control the accuracy of the punch operation. That's it. Cool. Yep. And I got out of sequence here, so sorry about that. But that's it. So, does anyone have any questions regarding split, mold, progress, strip design improvements? If not, oh, we have one. Okay. What's your question? Give you a second to type it in. While he's typing that question in, I'm just going to say the next webinar starts at 3 p.m. this afternoon, and it is the beginning of TopSolid CAM improvements. All right, so if we have a part from a step file, and with multiple colored surfaces, how to remove those colors. So, I'll show you quickly. Let's just go pick a part. Go up to here. So, the easiest is to go to the color command, select everything, and leave it unspecified. And then that will remove all the color back to whatever the default color was. Or you can specify in that command, you can specify whatever color you want it to be. Okay? So again, if you have imported models that come in with multiple colors, the other thing you can do is during the import, and let me see if I can find something for you here. So step file, whatever, turn off translate attributes during the import. That's another thing. So if you have translate attributes turned on during the import, it's going to come in with whatever colors that they were. If you turn that off during the import, it should come in just as one color. And is it available in 7.13? Yeah, the color command has existed since 7.0, so you're good. But if you're on 7.13, now's a good time to upgrade to the latest version.